Okay, now alpha iron, gamma iron, and delta irons are only the forms of pure iron in different temperature. Now, if we go to, I'm stopping the presentation of previous class. Now, I'm showing, I'm presenting the lesson of previous class. That is that is iron carbon system. This is the name of the module, and the next topic is iron carbide phase diagram. Iron carbide phase diagram is nothing but when some carbon is actually injected or mixed with pure iron. Now I think you have a slight idea about the steel. Steel is the construction material which is very much important in civil engineering structural construction. Steel is actually made from iron with a slight mixture of carbon. I think you can remember that in the last class we have discussed that some of the components like cobalt, nickel or carbon may be used as a mixture with iron. Uh, Cobalt, nickel or carbon may be mixed with iron to modify or precisely saying to improve the characteristics of iron, structural characteristics of iron. And most commonly used component is carbon. Carbon is actually the main component that is mixed with pure iron to make steel. Steel is already I have told that steel is the most important structural material in structural construction. That's why we have to know and we have to get a deep idea on steel. And before we can go to understand or study about steel and the structural uh, characteristics of steel, before that we have to understand the reaction and the phase diagram of iron and carbon system. Now, first of all, when we start to add carbon to iron, after some specific phenomenon, the iron and carbon will react in a specific content and make a specific compound that is called iron carbide Fe3C. This component is the most important component that is present in the steel, and this iron carbide is not formed from the 100% pure iron. That means there are some portion of pure iron and there is some portion of iron carbide, and that's why the steel may be considered as a alloy of pure carbon and iron carbide, and that's why we are studying here the iron carbon system. And in the system of iron carbon there will be a portion of pure iron and one portion of uh, iron carbide, and that is why the system may be considered as the binary system or two component system. And in the previous classes when we have studied about the phase diagram, we have studied that there are two types of phase diagram. One is for one component phase diagram and one is for binary phase diagram or two component phase diagram. And here the iron carbon system or the iron carbide phase diagram, iron and iron carbide phase diagram is one of the example of binary phase diagram or two component phase diagram where two components are iron and iron carbide. Okay, now now going to the phase diagram, I think I can largen the diagram to better understand. Now, now, uh, if you can remember the two component phase diagram or binary phase diagram, there are two axes. One is component axis, one is temperature axis. Temperature axis is nothing but that is y-axis, and temperature in degree Celsius or degree Fahrenheit is represented. And in composition axis or component axis, the component which is added or which is mixed, the component is represented in weight percentage of the mixture, that is represented in the composition axis or in the x-axis. Now here the composition is carbon, but but the two composition in the uh, system is, one is iron and one is iron carbide. But as the composition which is added to the system is carbon, that's why we are representing weight percentage of carbon in the composition axis. Now coming to the phase diagram. In the phase diagram, these red lines are the phase boundaries. We have studied about phase boundaries in the previous classes. Now these these portions these portions are actually portions of pure iron, which may make a solid solution after presence of carbon. After a slight presence of carbon, these portions these portions these portions are actually making some solid solution with carbon. Now uh, first first form of pure iron is alpha ferrite. Alpha ferrite, that is written here, alpha ferrite. And after alpha ferrite at 700, I think you can remember that the alpha ferrite form is actually up to 770 degrees Celsius, approximately 770 degrees Celsius, and up to 727 degrees Celsius, 727 degrees Celsius, the solution or solubility of carbon will increase. And obviously the solubility of carbon is not very high. The solubility of carbon is not very high up to in the alpha ferrite form of carbon, and that is only 0.022 percentage weight percentage of carbon. This is 0.022 weight percentage of carbon that is written here. And and that is maximum at a temperature of 727 degrees Celsius. Now, now there is one thing you may ask, that this phase diagram is up to 6.70 weight percentage of carbon. Now, what is the uh, meaning of this 6.70? And the question may be that in the previous phase diagrams we have represented these x-axis or composition axis up to 100%. Why for this? For in this case, the weight percentage is up to 6.70 only. Now that is why the reason is that uh, only 6.70 percentage of carbon is actually having the importance in structural characteristics of iron. Maybe if you may take the example of cast iron, or you may take some example of some steel. The percentage of carbon cannot be exceed this percentage, 6.70 percentage. That's why the actually total phase diagram of iron carbide system, total phase diagram means from 0 to 100%. That these axes may be extended up to 100%. The total phase diagram may be divided into two parts. One is carbon, one is carbon rich portion, and one is pure graphite portion that is written here. One is carbon rich portion that is not shown here, and carbon rich portion means that is not shown here, that is actually 6.70% to 100% of weight percentage of carbon. That is after this, that is not shown here, that portion is actually carbon rich portion of the phase diagram, and this portion is having no importance or a little importance in the characteristics of steel or cast iron, which is the important materials in our consideration. That is the structural material, structural steel or structural cast iron. Maybe you may take some examples of modified iron, and when the carbon percentage or the weight percentage of carbon is higher than 6.70%, that portion of iron having no importance or a little importance in that. That's why we are not taking consideration of that portion or that carbon rich portion. We are only taking consideration or taking in our discussion up to the 0 to 6.7 percentage of weight percentage of carbon, and uh, okay, and up to this is the boundary, this is actually the boundary of this portion, iron rich portion and less iron percentage. These two portion is having one boundary, that is this vertical axis. Okay, now now okay, now coming to this portion, this phase diagram, we have already discussed that alpha ferrite or the basic form of iron is having little solubility of carbon, and after the mixture of carbon, that alpha ferrite is making a solid solution, and obviously the solubility of carbon is very much little, that is 0.022 weight percentage of carbon. After 727 degrees Celsius to 768 degrees Celsius, that solubility will decrease. This 768 degrees Celsius is the last temperature of alpha ferrite, and the solubility of carbon will decrease up to 768 or approximately 770 degrees Celsius. That solubility will decrease. Now from that temperature to 800 degrees Celsius temperature, there will be a mixture of alpha and gamma iron, that is ferrite and austenite. We have discussed in the last class, that is ferrite and austenite, about ferrite and austenite. Austenite is actually the form of carbon after approximately 770 degrees Celsius, and uh, there is some mixture of ferrite and austenite in that position, that is after 727 degrees Celsius to 912 degrees Celsius, and and this at this position up to 912 degrees Celsius, we have discussed in the last class that this portion of carbon after 770 degrees Celsius to 912 degrees Celsius, this iron is having no magnetic property. That means this iron is not non-magnetic iron, and up to 912 degrees Celsius, the solubility of carbon is continue to decrease the solubility. This line is actually representing this. continues the decrease of solubility, and the maximum is the 0.022 percentage weight percentage of carbon, and that is at 727 degrees Celsius temperature. After that, after that 912 degrees Celsius, after the mixture of ferrite and austenite, there will be pure austenite or pure gamma iron, and the temperature range of gamma iron is from 910 degrees Celsius to 1404 degrees Celsius, or approximately you can take the temperature range is 910 degrees Celsius to 1400 Celsius approximately, but precisely the temperature is 912 degrees Celsius to 1404 degrees Celsius. Okay, you may write down all this temperature in your copy, because you may require these temperature ranges for your exam purpose. In the books you have to find all the pages to find out this temperature, but if you write these temperature ranges, you will get it easily in your copy. um, Please try to write down these temperature ranges of the forms of pure iron. Okay, now after 912 degrees Celsius, there is a form of iron which is called austenite or gamma iron, and for gamma iron for gamma iron, the solubility of carbon will increases up to 2.14 weight percentage 2.14 weight percentage, and that is obviously approximately 100 times of this 100 times of 0.022 percentage of alpha iron or ferrite iron. At austenite, the solubility of carbon is higher, and that is 2.14 percentage weight percentage of carbon, and that this maximum point is occurs at 1100 1147 degrees Celsius, and after 1147 degrees Celsius, the solubility will decrease. The solubility will decrease, and at a temperature of 1404 degrees Celsius, the temperature range of gamma iron will end up. That means at this position, the austenite or gamma iron will changes its form to delta iron and after this temperature 1404 degrees Celsius, the iron will modify to delta iron, and the temperature of delta iron is having a large similarity with alpha iron or ferrite iron. That similarity we have discussed in the last class, that is the molecular structure is like this. The BCC structure, I have taken one figure of BCC structure or alpha iron, and alpha iron and delta iron is very much similar in structure, only the this distance between the two molecules of iron is actually the different in two different forms of alpha and delta iron. Only the difference is in the distance between the molecules of iron. Other than the molecular structure is similar. And after that, after this temperature, 1493 degrees Celsius temperature, actually the delta iron will the solubility of carbon in delta iron will decreases and up to 1538 degrees Celsius or 1540 degrees Celsius, the iron will melt and it liquefied actually. That's why up to this we are stopping the phase diagram of pure iron with carbon. But But this is not actually the thing of actually the phase diagram of iron carbide phase diagram. Iron carbide phase diagram is actually these portions these portions after these these phase boundary here ferrite iron or alpha iron and iron carbide mixture is present. This is actually called cementite, ferrite, austenite, and this is called cementite, where alpha iron or ferrite iron and iron carbide mixture is there. Okay, and after these temperature, that is actually this is 768 degrees Celsius or 770 degrees Celsius. After this, sorry, 727 degrees Celsius. After this temperature, ferrite iron changes to gamma iron, and obviously the phase diagram will changes to gamma iron plus iron carbide, gamma iron or austenite plus iron carbide after 727 degrees Celsius. And after after this after this the temperature is very high. The temperature is very high, and if there is a mixture of carbon, then the system will be in liquid form. This is in liquid form, and that mixture will actually the alloy of gamma iron or austenite plus liquid iron. This is actually the mixture of gamma iron and liquid iron. But the question is that after 1414 degrees Celsius, sorry, after 1404 degrees Celsius, sorry, or approximately 1400 degrees Celsius, there will be a form of delta iron. But as the temperature is very high, we don't have considering this form with mixture with carbon, as this much of high temperature is not considered, or actually there is no technological importance of this mixture delta ferrite and carbon. Okay, sorry. And if the percentage of weight percentage of carbon increases, obviously the liquid temperature of melting or liquefying temperature will decrease, and of at a temperature of this 1147 degrees Celsius, there will be some part of iron will liquefy. Some part of iron will liquefy, but actual temperature of melting of iron is 1540 degrees Celsius approximately. But if carbon percentage is increases, carbon weight percentage of carbon is increases, the temperature of melting of iron will decreases, and at a weight percentage of carbon 4.3%, 4.3%, the melting temperature is actually the lowest, and that is 1147 degrees Celsius. That temperature is 1147 degrees Celsius. At a temperature of 1147 degrees Celsius, and weight percentage of carbon 4.3%, the this temperature is at the lowest point of liquefying of carbon in a mixture with carbon. Okay, but when there is no stress of carbon, no mixture with carbon, then the melting temperature is 1440 degrees, sorry, 1540 degrees Celsius. But when carbon percentage is there or carbon mixture is there, the temperature will decrease, the melting temperature will decrease, and at this weight percentage 4.3 weight percentage of carbon, the melting temperature is lowest, and that temperature is 11.47 degrees Celsius, 1147 degrees Celsius. Okay, after that the temperature will increase slightly. That is not very much important, but this portion is important. This portion is important as there is a mixture of gamma iron, liquid iron and carbon. These in this portion, in this portion there is a mixture of gamma iron, liquid iron and carbon. Okay, and anything left? Uh, I think you can see what I am writing. Liquid iron. For better understand, we can write as equation that is this sign is for two-way reaction, and if liquid iron is actually cooled, the cooling operation is done, then there will be liquid iron after cooling, there will be a mixture of gamma iron, plus Fe, that is iron ferrite, Fe3C, and obviously if this is heated up, then this portion will be made liquid. Okay, this is the actually equation form of the last part, this part, this part, when there is a mixture of gamma and liquid iron. If gamma iron and carbon mixture is heated up, then that will be made liquid, and if liquid iron is cooled, then there will be a mixture of gamma iron and iron carbide. And about the initial part, that is up to this and this part, you may write down one equation, that is gamma iron yes anyone want to say something gamma iron where 0.76 percentage of carbon weight percentage of carbon that means at this position is one of the boundary phase boundary and same cooling of that will actually given us alpha iron or ferrite with 0.022 percentage carbon in solid solution plus 6 you may write down Fe3 C and the percentage of this is 6 point maximum percentage of this thing is 6.7% of carbon. And here you may write weight percentage of carbon. Sorry, weight percentage of carbon. Here also weight percentage of carbon. Here also weight percentage of carbon. Like this, you may make these two equation of these two parts. There are two phase boundaries, two important phase boundaries. One is at 727 degrees Celsius, one is at 1147 degrees Celsius. When there is a mixture of carbon and at these two phase boundaries, these may be the equation cooling and obviously not only cooling. If you heat up the reaction will be vice versa. Okay, this is all about the iron carbide system, phase diagram of iron carbide system. and and one thing I think I have skipped that is the reason of this why the solubility of carbon at alpha iron or ferrite iron is this low and at gamma iron or austenite is high. The reason is that the molecular structure, what I, this structure, as there is one carbon at the center point, at the center of the cube. That's why the maybe you can say the uh, uh, accomplishment of carbon molecule or placement of carbon molecule in this type of structure is very hard. There is no vacant space in this molecule structure. That's why at ferrite or alpha iron state, the solubility of carbon is very low. But when the iron is at its austenite form, that is like this, yes, that is like this, and all the carbons are at the surface. Sorry, all the iron molecules are at the surface. All the iron molecules are at the surface. That means there is enough space to accommodate carbon molecules. That's why at austenite state, the carbon solubility is this much higher, which is approximately 100 times of alpha iron or ferrite iron. Okay, this is the reason of this kind of solubility change, abrupt change of solubility of carbon in these two states of iron. Okay, this is all about iron carbide phase diagram. I am stopping the presentation now. You may speak out and you may say if there is any problem, there is any query, any doubt.